Hi scholars, today we're doing lesson 4 in the same unit where we're going to be continuing to add and subtract decimals, but this time we're going to have many non-zero digits in decimal. So because of that, we're going to focus on using the standard algorithm today. To do so, we're going to start off by looking at two word problems and thinking about a couple of things when we read word problems. We should always think about what operation we're going to use to solve the problem, write a mathematical statement to help us solve it, and then find the sum or the difference. Let's start with number 1. It says, Lynn's grandmother ordered needles that were 3,125 ten-thousandths of an inch long to administer her medication. But the pharmacist sent her needles that were 6,875 ten-thousandths of an inch long. How much longer were these needles than the ones she ordered? Show your reasoning. So I want to first, as always, think about what operation am I going to do here. We see we're comparing two needles, and it says how much longer is one of them compared to the other. When we ask ourselves how much longer something is, we know that's going to represent subtraction. We need to find a difference between these two lengths to see how much longer it actually is. So to do that, I'm going to write my subtraction statement, which is 6,875 thousandths minus 3,125 thousandths. Now there's a lot of digits in these problems, so we're just going to use the standard algorithm here. I'm going to write this vertically and making sure that my decimals are representing the same place value in both numbers in my subtraction problem. And as always, I just subtract vertically each place value. So in the ten-thousandths column, 5 minus 5 is 0. In the thousandths column, 7 minus 2 is 5. In the hundredths column, 8 minus 1 is 7. In the tenths column, 6 minus 3 is 3. And then in my ones column, 0 minus 0 is 0. So to answer my question here, I can say that the needles are 3,750 thousandths of an inch longer. Let's apply that same strategy to number 2. Let's read it together, and then we're going to also go over it. There is 162 thousandths of a liter of water in a 1 liter bottle. How much more water should be put in the bottle so it contains exactly 1 liter? Show your reasoning. So again, I want to think about what operation should I choose here. And I see that I need to think about if I want to compare two sizes for water and see how much more one number is than another, I'm going to use subtraction to find the difference. So my math problem is going to be 1 liter minus what's in the bottle already, 162 thousandths. So I'm going to use again the standard algorithm, which is putting my decimals line up in my subtraction problem. And as we know, if we don't see numbers in certain place values, we put zeros there as placeholders to help us subtract. Right now, by yourself, can you please subtract these two decimal values and find out what the difference may be? When you subtract 1 minus 162 thousandths, you will get 838 thousandths. Check your paper and check on the screen what you see to make sure you are unbundling the place values correctly. So I'm going to say that 838 thousandths of a liter should be added to make 1 liter. So we're going to continue practicing adding and subtracting decimals by now doing some puzzles on the back of your notes today. Here are a bunch of puzzles, and we're going to see what should go in the blanks based on what numbers they provide. I will model one of them, and you will do the rest of them with your partners or by yourself after you have a moment to pause in the video. So it says to write the missing digits in each calculation so that the value of each sum or difference is correct. So number 1, number 2, we're doing sums. Number 3, 4, and 5, we're doing differences. And these are like little puzzles. I'm going to model number 1, and you will do number 2 after the model. So I'm asking myself, 404 thousandths plus some decimal gives me a value of 1. So right now, it's maybe difficult to see how to fill in the missing numbers in those boxes. But what I can do though is making sure I put my zeros as my placeholders to see how I can make this math problem true. Here's how you do this. You start from the way right and think to yourself, 4 thousandths plus how many thousandths gives you 0, which may mean possibly 10. So therefore I can think to myself, if I add 6 thousandths to 4 thousandths, I'm going to get 10. 0 will go here in a thousandths place, and I'm going to have an extra 1 carried over in the hundredths place value. Now I ask myself, 1 plus 0 plus what number gives me 0, or 10? I'm going to put a 9 here because 1 plus 0 plus 9 is 0, or sorry, is 10. And so I can put a 0 in the hundredths place and carry a 1. Ask myself again, 1 plus 4 plus what number gives me 0? I can put a 5 here because 1 plus 4 plus 5 gives me 10. The 0 goes in the tens place. Put a 1 above the 1's place value. So 1 plus 0 plus what gives you 1? I need to put a 0 here and decimal here because 1 plus 0 equals 1. So therefore what is in the boxes is 596 thousandths. Try number 2 right now and then check your work after pausing the video. What you should have put in the boxes is 0.1235 or 1,235 10,000ths. If you have any questions, you may ask here or clarify with a teammate why the answer is this answer here. Let's now try number 3 together in a model, and then I'm going to have you do 4 and 5 on your own. This time we're doing subtraction, and it's saying 7/10 minus some number, which decimal should go here, equals 12 thousandths. So right now, again, it's a little tricky to do, but what I can do is put zeros in places to help me see the problem. Now, right now what we see is tricky because we know that 0 minus a number can't really equal 2 because 0 is smaller than 2. So what I can do is before I guess what numbers go in those boxes, I'm going to start unbundling. And I only can see a 7 here, so I'm going to take a 10th from 7 to make 6/10, and then add 10 hundredths. Now I have enough hundredths to subtract, but I still have a 0 here in the thousandths place value. So I'm going to take one of the hundredths to make it 9 to add 10 thousandths. I can stop there because now I have enough thousandths. So 10 minus what gives me 2? I know that's 8. 9 minus what gives me 1? I know that's 8. 6 minus some number gives me 0, which would be 6. 0 minus some number gives me 0, that gives me 0. So my answer in the boxes is 0.688 or 688 thousandths. Right now, please try the number 4 and number 5 with a partner or by yourself. And after the pause in the video, you can continue to check your work. Alright, so for number 4, you should have 3.5433, or 3 and 5,433 ten-thousandths. And then for number 5, you should have 69.9911, or 69 and 9,911 ten-thousandths. Ask any clarifying questions you may have or check with a partner. And after you finish your notes today, you will work on your X ticket by yourself for today's lesson.